Let me show you how to be a good breezy and change your predictions after.
As you may know, I am kind of a nerd, and I also love football. I'm a PSG fan since I'm 5-year-old, so I've lived it all with this club. And yet, I've never done a European-centered football analytics episode because, well, the US are much more advanced when it comes to sports analytics. But today, I am happy to say this day has come, a sports analytic episode where we can actually talk about European football. And that is thanks to Maximilan Göbel. Max is a post-doctoral researcher in economics and finance at Bocconi University in Milan. Before that, he did his PhD in economics at the Lisbon School of Economics and Management. And Max is a very passionate football fan and played himself for almost 25 years in his local football club. Unfortunately, he had to give it up when starting his PhD. Don't worry, though, he still goes to the gym or go running or sometimes cycling. Max is also a great cook, inspired by all kinds of Italian food, and an avid podcast listener, from financial news to health and fitness content, and even a mysterious and entertaining Bayesian podcast. This is Learning Bayesian Statistics, episode 91, recorded August 23, 2023.
Let me show you how to be a good breezy and change your predictions after.
Maximilan Göbel, willkommen nach Learning Bayesian Statistics.
Thank you, Alex.
Yeah, thank you for taking the time. I'm really excited about this episode. I'm really having a variety of podcast episodes these days. Going from episode 989 is gonna get out in a few days, and you'll see it's about sport also, but it's about the science of sports and nutrition, of exercise and nutrition. And so today we're going to talk a lot about sports also, but more about football, or soccer as it's known in the US. So that's going to be a fun one. And I'm really happy to have you on the show because you are German. So if I remember correctly, Germany is in Europe. And so you would be the first soccer analytics episode, Europe-centered, which is cool. And yeah, it's one of the things I'm saying we should do more here in Europe. But before that, as usual, we'll start with your origin story. Max, how did you come to the world of econometrics and machine learning? Because it's actually what you're doing most of the time, if I understood correctly.
Yeah, you're right, Alex. Well, actually, it's been, well, if I say it's quite a journey, it sounds dramatic, but that's not the case. But it took me quite a while, let's say. Yeah, that's maybe the better framing. I started out in my PhD, basically the first years, of course, just some coursework, but I went into the PhD without really having something that I really wanted to work on in particular. So I took the first year to see which courses I like, which not. And at my university, it was not really a lot to choose from. I mean, we had macroeconomics, microeconomics, and econometrics, the usual stuff. But yeah, really nothing's resonated with me so much, I have to say. And then I thought I would do some macroeconomics. I think many people, or most of the people, or PhD students, really want to do something in that field. So it was also me. But yeah, I really never got familiar with that stuff so much, and I never really liked it. But in the second year, then there was a course on computational economics, and I liked that quite a lot. And it was also, let's say, a tough schedule. I had to prepare a proposal within a week, and I didn't have any idea about computational economics, but that really got me into looking into that stuff very deeply, or deeper, let's say. And, so yeah, basically what I was working on there was some clustering, some unsupervised learning, basically. But it wasn't really a fancy machine learning back then. So what I did
Mhm.
was like the project was related to clustering community structure in the S&P 500. Basically, that was the project.
Yeah.
And yeah, but I really thought, oh, this network analysis, this community structure detection, that's really cool. I want to work on that. Um, and yeah, so I thought this would be basically the outline for the rest of my PhD.
Hmm.
And how did I get into econometrics and machine learning then? Because it wasn't really related to, or not really machine learning, what I was doing back then. So
Yeah.
how did I get there then? It wasn't until the third year, basically, until I got luckily invited to the University of Pennsylvania as a visiting student. And I
Hmm.
got introduced, I got invited by Francis Diebold, and yeah, I'll be forever grateful for him for inviting me there. And he had a research group on econometrics, and at that time the topic was about climate. And I thought, well, I don't care about the topic actually. I just want to learn whatever, yeah, comes to me. And so yeah, I took that opportunity. He introduced me to his research group, and they were working on climate forecasting, climate econometrics. That's how I got basically really introduced into econometrics. Because before I went to the University of Pennsylvania, I thought like, yeah, I basically know what's going on, and I have this and this project, and that's cool. But when I really arrived there, I really got to know what PhD in economics is really about. And yeah, that was pretty insightful, I would say.
Yeah.
Um, and that's how I got introduced, basically through this research group, through projects that we were working on. And then there was one guy, he was Frank's RA, and yeah, he was working on machine learning in particular. And
Hmm.
basically, once, yeah, a couple of weeks in, he came to me and asked me, well, Max, you want to get me that and that data, and we can work on a project. And that started off a long, well, quite well, a couple of years now of co-authorship with him, with Philippe Coulicolombe, who is now a professor at UQAM, University of Quebec at Montreal. And he's working a lot on machine learning, and he basically introduced me to that sphere. And so in the end, it was the third year of my PhD that I got introduced into econometrics and machine learning, and yeah, quite late, as I would say, but yeah, better late than
Yeah.
never, maybe. So
I mean, better late than never, right? So that's cool, and you seem to enjoy that. So that's super fun. And so today, what are you doing basically? How would you define the work you're doing nowadays, and the topics you are particularly interested in?
yeah, well, that's a good question, and because everyone I got asked that question, I also already or always had a difficult time actually saying, because I was doing something here, something there.
Yeah.
So in between, I also thought I would like to get back to macroeconomics actually, but after spending a couple of months on something there and it didn't really work out, I completely ditched it, at least for the meantime. Um, so what I'm working now is basically, yeah, machine learning, macroeconomic forecasting, let's say. I had a project on recession forecasting in the United States, which is probably a hot topic currently. Everyone is awaiting it, but doesn't really seem to occur. So maybe we have to wait a couple of months more. Um, and then the other stuff is basically related to climate, a lot of climate forecasting, especially about Arctic sea ice, how Arctic sea ice is projected to evolve in the future, not only in the near future, but also in the, let's say, longer run. So
Yeah.
when Arctic sea ice might potentially disappear, there are a couple of
Hmm.
projects on that. That is still like related to that climate econometrics group. And then the other stuff is basically, yeah, machine learning. And I got really interested in finance, asset pricing, what you can do, like, yeah, kind of predicting stock returns, using machine learning tools there. That's super fascinating. And yeah, just, I mean, I have to say that I'm not a specialist in machine learning or so. I'm just super interested and fascinated by the tools and
Yeah.
the problems that come with them. So yeah, there's a lot of, well, very powerful, but applying them to finance and economics also comes with some drawbacks. And so, yeah, you have to work around that, and it makes it super interesting.
Yeah. 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 No, for sure. And I mean, that's probably by being really interested in a topic that you end up being a specialist of it, right? So it's like you don't really start being a specialist and then being interested in the subject. I'd say the causality go the other way around. So um, that that's
Exactly.
good. Like trying a lot of things is how you end up finding what you're really passionate about. So yeah, awesome. And I'm curious, actually, in the research realm of economics, which tools do you use, machine learning tools, to work in these models? Like I'm guessing a lot of open source package. I'm hoping, because I remember I was introduced a bit to, I mean, I knew a bit the econometrics economics field in Europe a few years ago, and they were using stata all over the place. So I'm curious if that changed and how that changed.
Oh yeah, that's a funny question. Really, because Stata, yeah, I mean, some people love Stata. I'm actually at the complete other end of the, let's say, of the distribution. I always try to avoid it as much as I can. I don't know. I never really, yeah, liked it. So what I'm using is basically R and Python. I
Okay.
also worked a bit on MATLAB. I like MATLAB actually a lot.
Hmm.
But yeah, now I'm mostly working in R and Python, and it really depends. Sometimes I prefer R, sometimes I prefer Python. For machine learning, I'm mostly using Python. Well, let's say for machine learning, I'm actually using R, let's say, when it comes to random forest or
Hmm.
gradient boosted trees or something like that, or just plain lasso or ridge. Um, but when it comes to deep learning, then I'm using Python. So TensorFlow, now I'm trying to switch to PyTorch actually.
Hmm.
And yeah, so that's basically the patch that I'm using. Yeah.
Yeah, interesting. And how do you choose the tool, the particular tool you're using for a particular project?
Yeah, that's a good question. And I think that's always mostly an art than a science, I would say, and it's up to your preference. But not all tools work in every context, right? So in economics, it's really the problem, especially in, I would say, macroeconomic forecasting, where you have like a time series of, let's say, it gets until like 700 observations on a monthly basis for the United States, maybe. And then you have a feature set of, let's say, 100 features. When you include lags and all that, you can, yeah, pump it up maybe to 1,000 or something. But for machine learning or for deep learning, this is still rather small data set, I would say. So that's ridiculous. Um,
Hmm.
but still, that's then the challenge, right? To tune them, to train them, so that they don't overfit, and that's really the interesting part for me, I think. And yeah, in other contexts, other tools might work much more um, conveniently, let's say, or are much easier to apply, or so some lasso or so when you have a lot of features and you just don't know which features are important. Um, then yeah, I like lasso in that regard because it, yeah, selects basically the features for you. Um, or you might say, well, you're in an asset pricing context, you have returns, a lot of noise in there, signal to noise ratio very low. You really don't know which features are important, so ridge is maybe the better option because lasso would basically set almost everything to zero. Yeah, so yeah, it really depends. You really have to yeah, make it dependent on the context that you're working in. And yeah,
Hmm.
but that's also interesting to see which models prefer work well on which data sets in which context. And yeah, I'm still learning in that regard, and that's super interesting.
Yeah, yeah. No, for sure. And I find that super interesting also to see this ability of open source tools to basically be adopted more and more in research, which, of course, I'm like extremely biased, but I welcome. Uh, but also mainly because I do think that open data and open source are natural um, consequence, but also cause, I would say, of more open science, which I definitely welcome, and I think should be way more the case. Like more and more you see papers with accompanying GitHub repositories and accompanying GitHub open source packages, even in Python or in R, which is definitely something new. And that's super cool that the research realm is catching up on that. Because less and less you see papers where I remember a few years ago, like the first open science or open data papers was like, oh yeah, the data is available, by the way, at the end of the paper, and then you had to basically beg the corresponding author about like 3 times a week for 4 months to get some of the data, and that was not really open, basically. So yeah, that's a really cool development that I really love. I have to say.
No, absolutely, and this is also, I think that's a very good point. For example, me and my co-authors, my co-authors are pushing for that, really, to make the codes then also available on the website, for example, so that people can cross-check, and that's very good. And yeah, I like that also myself when I read papers and I want to replicate something, and the authors are making the code available. Basically, you can check if your own code is correct. That's super helpful. You learn a lot by that, and yeah, really, especially when, for example, using boosted research. So I mean, it's XGBoost, and it's super convenient to use. And for sure, there's some tuning that you have to do yourself, and but still, the package is there basically, and it's super convenient to use. You don't have to code the whole forest basically yourself. So yeah, no, for sure, that's
yeah,
amazing.
Totally. Yeah, that's super nice, and well done, and like picking up all those different tools and different languages. That's super cool. And I don't know how it changed, but I do remember that a few years ago, doing open source development wasn't really incentivized for doctoral candidates or postdoctoral candidates. So maybe that changed, and that's for the better. But if that didn't, the fact that you're doing it is like even more commentable, I would say, because that's that's not really, that's a bit adjacent to your project. So yeah, well done on doing that and taking the time to do it. That's super cool for sure. So now I'd like to talk a bit about, so you said you're doing econometrics, but can you define econometrics for us and tell us what it brings to economics, basically?
Yeah, sure. So a lot of weight now for me on giving the textbook definition of econometrics.
Yeah, exactly.
No, I mean it's basically, or now I'm butchering the whole definition probably, but it's applying statistical tools to an economic context and trying to use statistical tools to basically verify some economic theory or to understand some relationships between economic variables. So I think it's I think that's basically it, and it's kind of a fancier term for what it actually is. Applying statistical tools for understanding economic relationships, I would say. That's basically it. And it's essential. I mean, for empirical work, for sure, there are economists who only work on theory, but for policy analyses or for you need to analyze the data in the end, and basically that's what I'm doing. I don't really do theory stuff, but for me it's just all empirical, and so definitely it's very useful in the end, especially for policy making at central banks and everywhere, also for in the industry, be it banking industry or be it just normal in the real economy for analyzing demand and all that. So yeah.
And do you so I'm curious how you got introduced to Bayesian methods, actually, and why they stuck with you, because from what I remember from the world of econometrics, Bayes was not used a lot in this field. So I'm actually curious why you are using it.
Yeah. well, I have to admit, like, so I already said that it was like third year that I got introduced into econometrics, and there was this project when Philippe, Frank's RA, basically came to me and asked me to gather some data on climate variables because we want to run a vector autoregression of the Arctic. Basically, you basically get some. What we basically did is we gathered data, or time series on certain climate variables, which we thought would proxy for the Arctic ecosystem, basically. And then we wanted to use a vector autoregression to analyze certain amplification mechanisms if there is a shock to CO2, for example. And also to be able to produce long-run forecasting projections. So when Arctic sea ice might potentially disappear in the future.
Yeah.
And so the data is highly non-stationary, and in VARs, when you work with VARs, most economists really work with Bayesian methods there. And as I said, data was highly stationary, so Bayesian statistics or the Bayesian framework gives you some leeway there, grants you some freedom there. So that was that was why Philippe then told me, okay, look at Bayesian VARs, look at the Bayesian way. And that's how I actually got introduced to that. And there was, at the time, I really didn't have any exposure. So there was a package in MATLAB for doing Bayesian inference, basically, with VARs. And that was super helpful. That helped me a lot. That was super or a great education, a source of education, really. That was great. And the more I learned about it, the more it resonated with me, this concept of quantifying uncertainty. I think this is, because especially in economics, this is quintessential to really get an idea of what the uncertainty is. I mean, point estimate is always nice, but you want to have the uncertainty around it. And that's also what Frank Liebel always told us. You want to have a measure of uncertainty. And definitely that's true. And yeah, you get it from in the Bayesian framework. It's just so intuitive to think about it, I like that a lot. And unfortunately, I don't really work so much, or haven't worked in so many projects with Bayesian methods lately, or not as much as I would like to. But yeah, it's ever since resonated with me, and still, I wanted to learn more, and that's how basically I got into looking at PyMC, because I wanted to learn Python, and thought, well, maybe an application with Bayesian methods, the Bayesian framework would be cool to learn, and that's how I got on into PyMC3 or PyMC basically, or looked at it. So yeah.
Yeah. Nice. That's interesting. So yeah, basically it's like the uncertainty quantifying that was really important to you. Yeah.
Exactly. So that was really the key point there.
Yeah. I mean, that does make sense, right? Because that's really one of the parts where Bayes does shine a lot. And also especially for the Arctic sea ice project that you were talking about, it's not like it's a reproducible experiment, right? It's really hard in these cases to think from a frequentist framework of repeatable experiments. You cannot have multiple Earth on which you can do RCTs where you melt the ice caps or not, and you melt it naturally or thanks to human intervention. It's just it doesn't work in that case. So yeah, Bayes, I'm not surprised that it would be a project where Bayes fits way more naturally.
Yeah, no, that's for sure. I mean, for example, these climate models from these climate institutions, and these are huge models and big models. To train them, or to run these models, it takes a lot of time, and they are very sophisticated, so really, really sophisticated. But they're basically deterministic models, and they give you a point estimate in the end. But our interest was basically really to see, well, we get a point estimate, but we also want to see, especially when we project the path of Arctic sea ice, the uncertainty around it. Well, how likely is it that maybe that we see Arctic sea ice disappearing, not at our point estimate in the 2060s or 70s, but beforehand. Like, how large is the uncertainty? Maybe our model is really not good, and the uncertainty is so much all over the place that it's more or less useless. But in that project, it was actually interesting to see that the uncertainty or the credible region was basically spanning like 20 years, 25 years around. So that was very interesting, and it gave us a quick quantification of uncertainty too. Yeah, that was really interesting.
Yeah. Nice. That I love that. And I mean, that's really interesting for me to talk with someone who recently got into the Bayesian framework and to understand how you got into it and why and how. So I would have a lot of other questions on that, but I want to talk about football or soccer. So let's switch to that, and then if we have time at the end of the episode, I'll come back with my nerdy educational questions. So yeah, basically you have an area or a hobby of yours where you do apply and need actually Bayesian stats, and that's soccer analytics. First, I read a bit your website, and I saw you were passionate of football since you were a child, and you mentioned a bunch of European championships. Not the French one, though. I was absolutely outraged. What happened? What happened? Don't you get the French games in Germany?
Oh yeah. Oh well, that's another issue. So when I was younger, really, I mean, it was only the Bundesliga, and sometimes when you were lucky, sometimes you get the highlights of the French league, the Premier League, and the Serie A. But you had to be really lucky. It was not always available, and I wasn't that. Um, yeah, I didn't know the websites where you could watch it, basically. So that was another issue. But yeah, the French league I was never really a fan of. I'm sorry, Alex, but yeah, that's just. Even though one of my favorite players was Joao Goku, Olympique
Oh,
Lyon.
really?
Yeah. So
He went to Milan. Yeah. Yeah. No offense taken. I think the French league is pretty boring. As long
That's the
as
Bundesliga.
as long as PSG is dominating like that, that's good for me because I'm a PSG fan since I'm like 5 years old. But yeah, it's not a very interesting league, and the level is kind of going down by the years. So hopefully we'll get some investors in other clubs, which make for good competition for Paris. But until now, it's really bad, and it's actually bad for Paris because the competition inside the country is really bad. So then when they get on the European stage, they are not really used to the intensity and having so much adversity in a way. So it's too easy for them, let's say. So basically, but I didn't get you on the show to trash the French league. I want to talk about a soccer factor model that you recently worked on, and I found it super interesting because that's mainly the main question I always have in soccer analytics. The nerd in me is always very careful about the hot takes that you see the commentators have about players, where it's like, yeah, but how do you separate a player's skill from the ability, skills and ability from his team's strength? And that's, to me, is extremely important because mostly in Europe right now, most of the clubs mainly invest on players on gut feeling, basically. And the thing is, when you do that and you're not able to separate inherent player abilities from team strength, then you get kind of an aura effect from the beginning of your career that can follow you, even though you're not that good of a player. But basically, this aura can follow you, even though you are not making that much of a difference. but it's just like it's hard to contradict it because you don't really have the method of the scientific way of disproving basically what's going on, and that actually, well, it's not really your inherent abilities, but mainly the people you're surrounded with. And I think it's like absolutely important to do that, and should lead to really a revolutionized way of transferring players and signing them and so on. So that was basically the background for people who are not interested in football. Even if the field doesn't interest you, I think the method and the goal of the model is actually extremely important, because you can also think about that in finance, for instance. Like, I know a lot more work has been done in finance for that, because I mean the return, or like basically the incentives of the money are much more important, because you know if you make money or not. But like I know there is a lot of literature, right, on basically passive investment versus active investment, and like how do you actually prove that an active investment is better than a passive one, and that it's actually due to the skills of the person who invested on the market instead of just random market fluctuation. So like you can see that in a lot of context where basically information is sparse, is hard to decipher, and so you need a model to make sense of it. So you can see that, I would say, in football, in a lot of sports, in finance, in medicine also, right, where it's like you can have a lot of these celebrity effect, basically. I think in a lot of contexts where celebrity effect is important, it can be broken down by that scientific way of estimating it. So these politics, of course, movie, like I think it's basically a theme that's running in a lot of fields where the celebrity effect is extremely big. So yeah, that was a very long introduction, but to say that I think it's very useful. So you can react to what I said, and also afterwards, if you can tell us what a factor model is, because your model, you called it the soccer factor model, but then can you tell us before that what a factor model is?
Yeah, no, Alex, I mean, you laid it out perfectly. I couldn't have said it any more accurately, I would say, really on the point, as far as I see that. So a factor model, what it actually is um, a factor basically is I would define it as some proxy for a certain exposure to a certain in finance to a certain risk, basically. Also a reduction, for example, in when you look at economics or macroeconomics, it's often related to the context. You have a huge set of features and you reduce it to a couple of underlying factors or a single factor only. It's a kind of a feature reduction, like dimensionally reduction technique, like PCA, principal component analysis, or that. But in finance, it's really like a kind of a proxy for a certain risk exposure that basically kind of the cross-section of stock returns, or all stock returns, are kind of exposed to a certain systematic risk exposure. All stock returns are basically exposed to it. This is basically a factor, and you have in the literature in asset pricing has identified several of these, and common risk exposures basically across the whole universe of stocks, basically. But as you already said, you can use it also as quantifying the ability, for example, of a portfolio manager. So if he has some skill in the game, basically, if he has like really superior selection potential, than just following along these common risk exposures, basically. And that's also what this soccer factor model basically is inspired by, to identify certain features that kind of all players are exposed to because of the differences in the teams. And then when you account for that, then you can basically extract the skill and the inherent ability of each player after you account for these systematic differences across teams, basically, that influences the ability or the observed performance of the player.
Yeah, for sure. Yeah, for sure. Because like in the example of football, like you'd say it's easier to be the number 9. So the how do you say in English that position, like the front, like playing number 9 is like the guy who's supposed to score the goals. Like the English natives can then tell me what the name is in French. That would be attaquant. Um, like it's easier to be the number 9 of PSG than the number 9 of a very small team in France, right? Because the rest of the team is stronger. The manager is supposed to be stronger, and so on. So, like, yeah, you're like, yeah, but maybe if you took the number 9 of the small team and you put it in Paris, maybe he would perform as well as the current number 9 does. So, how do you make the difference? So that's what we're going to talk about. Before that, I'm curious from a structural standpoint, these kind of factor models, how do they work? Like, how much time do you need to really start to decipher the difference between inherent skills and exogenous, basically, strength? And that question is basically how much data do you need from the past years to start having an idea, like how data hungry are those models?
Yeah, so that's definitely a good question, a good point. So you have to create these fact, or yeah, you have. So in the model that I'm basically proposing is basically I need a lead time into the season to really account for certain differences. So I need a couple of games already that would need to be played to really account for differences in teams, because before the first game, basically everything, or based on the data that I had, everyone would have been the same. But it depends really on the data. If you have data that allows you to account for differences across teams, budget, let's say, or so, you can just start right away. And for overall data, I would say like more data is always better. If you have only a few observations, I think the Bayesian framework is then tailor-made for that as well. Like it grants you some leeway there. But I would say really it's the more data you have, the better. But yeah.
But you could already, so you could already start having that idea with just a few games. Then you get the idea of the strength of the team, and then you can start deciphering the strengths of the player.
Exactly.
Okay,
So,
yeah.
but as far as I always used a kind of a certain number of, let's say, burn-in games to really account for that.
And I mean, it's not that superficial, right? Because you can think, like, right now it's August, it's the beginning of the leagues for the European teams. August is a weird moment where the teams are still warming up, basically, and they are clearly not at peak performance. Usually they try to peak around spring for the Northern Hemisphere, so around March. From February to May, basically, they are trying to get their peak. So they are still warming up. They can still trade players until the end of August. So you could really say that the games they are doing in August, even though they are official games, they are still warming up games and don't really mean a lot for long-term performance perspective. So that's an interesting moment to start, warming up the model, I'd say. And so, but something I mean, and maybe you have that for future iterations of the model where you could put in the priors. We're going to talk about the structure of the model right away, right after that. But something I'm thinking about is that you could put in the prior the information that you have about the strengths of the team in the way that, you have the budget, which is a good proxy for potential future performance, but also like just past performance, right? If you know that Paris has been the champion for 9 years out of 10, well, you have really good prior about the strengths of the team, right? So you can probably also add that into the model, and in that way reduce the warming up period of the model in a way.
Yeah, no, absolutely. Or how, Paris against Lyon, let's say, has performed in the past. So their the direct comparison between those teams, basically, when they faced each other the past years, that would also feed in there. So absolutely, there's a lot of potential, and my model is when you're basically suggesting this stuff, my model just appears like very rudimentary, but could be definitely extended in that regard.
Yeah, I mean that's the fun thing of modeling, right? It's like you have to start somewhere that's good enough, and then you have a lot of ideas to extend it, and it's a never-ending endeavor. Like each model, if you wanted to, you could work on it your whole life. If you're interested enough, you definitely can do that. I know my models that I often revisit are the ones for predicting French presidential elections. When I started doing that in 2017, and compared to the one I had for 2022, it's just embarrassing. So, but in a way, it's good that the work you're doing right now is the best one you've ever done. And in a few years, when you look at the work you're doing right now, it kind of should be the worst you've ever done, because that means you've progressed a lot in the meantime. So I think it's a good mindset. So how did you adapt that factor model for soccer? Like what does the model structure look like, basically, for listeners to have an idea? And for those watching on YouTube, you can share your screen, actually. So if you want to share anything at some point, feel free to do it. Otherwise, the audio format is here for you, because it's a podcast, so it's an audio first content.
Perfect. So maybe if I get it on the screen, I'll do that. But for now, maybe the structure, I think, is pretty simple. And as you laid it out already very, very accurately, it's basically trying to come up with some features, do some feature engineering that basically accounts for differences across teams. And well, when you look at, let's say, a certain player, let's say Cristiano Ronaldo, and you really want to account for the difference that his current team is currently between his team and the team that he's facing at that exact instance. And you want to create some features that can proxy for these differences across teams. And that's basically the heart of the model. And this is basically inspired by these asset pricing factors that try to account for differences across assets, across stocks, across firms, basically. And the modeling part itself is really nothing sophisticated. You include kind of a hierarchical structure, but you don't need to, but it can help, definitely. But it's really the feature engineering that is at the heart of it. And then IMC comes in very conveniently and just basically does the dirty work for you.
And so then that's cool if it's a simple structure. Can you talk about what was your likelihood, and then what kind of distribution you put on the parameters and things like that? I think it would be a fun thing to talk about for the listeners.
Yeah, so the structure basically is relatively simple. You need some idea of what the performance of the player is, and you have to have a proxy for that. And well, you need this performance to be observed, obviously. And the proxy that I choose for a player's performance is whether he scores a goal or not. So 0 or 1 in a certain game. It's basically Bernoulli distributed, our Y, our target, and it's basically a logistic regression that we are running. Because what we want to identify is really the skill and the ability, a latent variable hidden in our observed performance measure, basically. And so the model is pretty simple. You need you have basically a bunch of coefficients. That is, you have the alpha, the skill, the ability that you're interested in, and then you have the loadings, the coefficients on all the factors that are in your model. You basically have to impose priors for all the coefficients, and then you have to define the likelihood, the nully distributed, and that's basically the model. It's on the workbook, and people can go through it. There's also a redacted version, basically, where people, if they're fancy, can try to work with their own priors and all that, and try to do it themselves first, and then check the unredacted version.
Oh, that's cool.
So if they want to play with that a bit.
Nice.
Yeah, that's basically it. So it's nothing really crazy. It's 4 lines of code, the basic model, basically. And when you look at multiple players, so you can do that for a single player only, but you can also do that for sure for multiple players. The key reason is that basically everyone should be exposed each player should be exposed to these factors with the same loading, basically. So you can impose a hierarchical structure on the ability and the skill of each player. You should definitely do that, but you can impose the hierarchical structure by player or also by season. So the ability of the player may evolve over seasons or across seasons, basically. That's, I think, something worth looking into or worthwhile doing. And then basically you have the loadings on the factors, and that they should account for the team effort. Basically, you want to account that, and you want to get that out of the way, so that you're basically in the end left with this latent factor, the alpha, the inherent skill and ability of the player.
Yeah. Okay. Yeah, that makes sense. And I mean, for sure, I will put all of these in your episode's show notes. And actually, I think I can share my screen. I don't know why I didn't think about that before. And here is the notebook, right? Am I on the right notebook?
Exactly. Yeah. So there are a couple of notebooks there. So there's this in the PyMCon folder. That's the one where there's the redacted version and the unredacted version, and the version that we're currently looking on, that's the initial part with all its typos in there. And
okay. So it's not the right one then. Should look at
another one. It's fine one. So it's perfect. The other one is just a bit smaller and a bit more concise, I would say. And
here, unredacted. Perfect. Yeah, I have it here. So yeah, like for those of you watching on YouTube, I'm sharing it right now. And so basically, this is the part of the model where you're talking about the likelihood, where its goal is scored or not scored, and then you have here the probability, which is basically here this alpha that you talked about, right? That is the inherent skill of the player, which enters probability, and you have the x's and the beta. So the x's, are they the factors, or the beta are the factors?
Exactly. So the x's are the factors. These are the differences across the teams or between the teams.
Yeah.
And this is what you want to, basically account for. And to clean the observed performance metric from.
Yeah. Oh yeah. Okay, I see. Yeah, for sure. And then the beta is the slope, basically, on the factors. Yeah.
Exactly.
Okay. Yeah. It's a fun model. So of course it's hard to make it justice on the podcast, but I encourage you to go and watch that part on YouTube. I'm sharing it right now, and also you can just take a look at the notebook from Max, which I put in the show notes, where you have all the details. So it's pretty fun to look at. And also, as you were saying, the model is like pretty small. So that's the amazing thing, right? That I find is that basically, and now if we go look at the PyMC implementation, so a bit later down in the model, the really cool thing is that basically the model is quite easy to code, right? And in a way, that's just a few lines of code, so basically 4 lines of codes, as you were saying, and you're done. So that's the beauty of the probabilistic programming framework, right? It's a really useful model, but if you want to get to a first good enough version that already gives you interesting insights, you don't have to reinvent everything, and you don't have to go with the first hardest version from the start, right? Where you have a hierarchical time series model where everything is varying and pulling information. Sure, that's cool, but don't start with that, right? It's like if you're starting to train, don't start with 100 push-ups. Start by like try 5 first, and then do a few series of them, and then build your way up to 100. So that's the really cool thing I find of here the Bayesian framework, coupled to the power of probabilistic programming languages, which is you can get down to a first good enough version, and then in a few line of codes, having your version, and then sampling from it. Right? Because here you have it on the screen, the likelihood, then you have a line for deterministic, which is the logistic regression line, and then you have your intercept and your coefficient on the factors, and basically that's it. That's really amazing.
Absolutely. No, that's I think the beauty of PyMC, that it allows you to describe or build your model in a pretty intuitive way, and you can even let it be printed out to see if everything is as you would have expected. And then PyMC does the dirty work, the sampling and all that for you. And but it already gives you an intuitive idea of how the modeling works. And that's absolutely super cool.
It's really fun. Well done on that. And so I'm curious, what are your do you have any ideas? Like, do you want to keep working on this model? Do you have any ideas on where to take it from what it is right now?
That's a good question, actually. So definitely the model is can be improved, and definitely it's all depending on the features that you have, on the data that you have. And I think the clubs, they have so much more interesting data than I have, and they could build many more interesting factors accounting for differences across teams.
Sure.
So I really don't know, because I tried to reach out to a couple of clubs, let's say, but there was nothing really coming back. So apparently clubs are not interested in that, or maybe they have their own models already or something. So I really don't know. I'd be excited to work on that, but as you said, it's rather a side project that I did once upon a time, and it's not really related to economics or finance. That's why I'm currently working absolutely on other stuff. But I would love to work on that in that regard. But it seems not so many teams are picking up on that, at least to those that I reached out, and it seems to be European clubs. Because in part of your last episodes, I heard people talking about that in the United States. It's pretty different, and there are apparently a lot of clubs already trying to implement that, to really trying to understand the inherent latent skill of players, not necessarily in soccer, but in baseball or in other.
Especially baseball. So this is sad, but I'm kind of reassured to hear you say that, because I do think it's a huge area of improvement that there is in Europe, and clubs just don't seem to be very interested. The thing I know is that a few English clubs are using data pretty heavily, like Liverpool, Manchester City, clubs like that, but it still is kind of the exception. I know Toulouse now in France, which is a small club, and that makes sense, right? If you're a small club, you have less money, so you have much more competitive pressure to find good players, which you are not overpaying, which is basically where science can help you, right? You don't want to pay for just a name. You want to pay for someone who has a name because he's got talent, not just because he's got a name. So it's like to me, everybody should do that, and I just don't understand why they don't. Because it's just like that's also the beauty of sport, right? You don't care about the name; you care about what someone can do and if they have talent or not. Like you should not care at all about the name, about the color of the skin, about nothing else but what they can do on the field. And yeah, like to me, that if I had a club, that would be one of my first priority. How do we make sure we optimize the way we are signing the players, because it costs a lot of money. So I don't know.
I think one club that also does a lot of that data work is in Denmark, the FC Midtjylland or something. I think the name I got it completely wrong, but I heard once upon or that they were really investing a lot in data science and trying to sign players according to data, or at least incorporate data a lot of in their also in their daily training exercises and all that. So yeah, they are one of the cutting edge maybe there in Europe as well. Small club, but yeah. I think they won the Danish championship like a couple of years ago. So yeah.
Yeah, not surprised. I mean, something I see a lot, at least in France, and I've seen that a lot also on electoral forecasting, is basically this idea that if you start doing that, you're basically becoming kind of inhuman and you make players being robot, basically. That's really an interesting thing to me, because one of the sports that really use data heavily is cycling. And so in the Tour de France, a lot of the teams are using now data. Here, again, thanks a lot to the British, which often who often in Europe are the first ones to take up the data wave. And so I know, for instance, Bradley Wiggins, I think he's won the Tour de France. I don't remember how many times, but a lot of times. And basically a lot, like the whole team was using data to optimize the performances of the team. And that was one, like the British started being like, okay, we need to get back on our cycling game. They started using data extremely optimally, and well, they did. And thanks to this, basically a lot of the teams started to do that again. And the Tour de France is extremely optimized on that. But it's funny because when you hear the mediatic coverage of that, at least in France, it's a bad thing. Because it's like players are becoming robot and they cannot eat what they want at the time they want. And they like, it just gets the magic out of the Tour de France rules. And I strongly disagree with that, of course, because the performances get better in a clean way, of course. Well, then that's just better for everybody, because the show is going to get better. And also, we're talking about the Tour de France are professional athletes. Like, their goal is not to recreationally do that. They do that for a living. So it's important for their own, basically, income. But also they do that because they want to be the best. They are not doing that because, well, they just want to cycle on the weekends, right? They cycle for a living. So yeah, sure. If you're an amateur cyclist, then okay, you don't need the same structure as a professional cyclist. But even then, if you want to improve your performance as an amateur cyclist, you're going to need to optimize some of the things. And if you really care about it, you're going to need to optimize your nutrition, for instance, and maybe when you take your meals or else. But if you're a professional, the one slightest change can mean you perform 1 second better or 2 seconds better, which can make you win the Tour de France or not. So I don't understand this argument in this context where you're trying to optimize performance. For me, it's like not something that should count here. They are not doing that for pleasure only.
Definitely. Absolutely agree. No, absolutely agree. It should be incorporated much more, especially for the clubs. In the end, it will, I think it will pay off as you laid out. I mean, you want to pick a lemon and you just grab a pick.
Yeah. No, I mean, I have to say it's like, it's an interesting topic for me because I'm trying to crack that nut and I cannot crack it for now. Like, understand why basically the clubs in Europe are not really interested in that, because I don't really care about the journalist side or else. I'm like, once the club starts picking that up, then everybody will have to. But what I'm trying to understand is why the clubs don't do that. Because it's just leaving gates on the table. And I'm just super curious about why they would do that from a sociological standpoint, honestly. Because I've seen a lot of clubs they have data science teams, but they use it for marketing. And I'm like, what? That's such a
I
shame.
see.
And I don't know why. So if anybody knows, please get in touch. If anybody is working in a club, please get in touch with Max or me, because I want to know about it. We don't even need to work together. I would be happy to help you out with a model, but for now, I just want to know why and what are the internal factors, because definitely there is something going on, but I don't know what it is, and I'm just curious about it. So yeah, to try and make it a bit more constructive, like, do you have any idea on like how we personally in the data world could change the status quo in that regard? And not only for sports, but that's also true for a lot of domain where a more robust application of the scientific method would be useful, but it's hard to get it done. Do you have any ideas personally on how that status quo could be changed?
Yeah, I think it's really hard to say. It depends on the willingness to adopt these, to be open to these methods, I would say. And the players play an important part, or I think the crucial part, because if the players are not willing to adopt these additional insights, I would say, it's just not possible. But for sure, I mean, as you say, it's management, it's internal things that are going on there, politics potentially. But I really don't know. How can someone resolve that? I don't know. I regard it always as, for sure, you shouldn't base all your decisions on this model or on a single model or so, but it can help
No, for sure.
stimulate your decision process. And I think it's a useful addition. And in the end, for sure, there might be an upfront cost basically to implement, to get the data, to implement the model, to hire people to produce that. But in the end, it actually may pay off economically, because it may save you from picking a lemon, overpaying massively.
Oh yeah, for sure.
I see it really as a worthwhile investment, and I think the US sports has demonstrated that. So
yeah. I mean, just look at the US. Just look at all the other fields, especially marketing, for instance, which is starting and already started to adopt data analysis and modeling aggressively, and they just we do that a lot at labs, basically making them save a lot of money, and not only save money but make more money. So it's just I don't think this is a question, but yeah, I mean, something you can do, I would think, if you're interested in it and have the time, something maybe that could work is if you could make some predictions with your model, basically. And I would think to get it per player, you would probably need some hierarchical structure in that to get some better predictions. But once you get there, you have something of a web page with basically the predictions of the model per player, saying basically this player is basically overvalued and this player is undervalued, basically based on the results of the model, and then basically see what that gives you during the season. Because if at the beginning of the season you can say that player is basically undervalued, he's going to perform better than what the market currently think, and then people see that it's true, well, that's a clear sign that basically these kind of methods and models are working, and so that could spark some interest, because definitely demonstrating what a model is for. Because my hunch, I think it's hunch. My hunch is that basically the decision makers in the clubs are not data. They don't really know what data is about, and they even don't know what a model is and what it can give you. But if you are able to demonstrate what the model can give you, because they don't care about the model, the priors, the parameters, stuff like that. They just care about the results of the model. So if you can demonstrate the results of the model, and even better, what the model can say about recruiting that player or not recruiting that player, that would maybe have a better impact, or at least I would say it increases the probability that the impact these methods can have get noticed.
Oh, absolutely. That's absolutely the case. For sure, it depends on having the real-time data, basically getting the real-time data.
Exactly.
That's I mean, an upfront cost that you would have to pay. No, but that's actually the intent. Really, this is the intent to run that model for multiple players as part of the workbook, for example, to lay it out and to compare which players perform well or not. And you see it, for example, Cristiano Ronaldo when he won the World Player of the Year award in 2008. He was basically in the middle of the pack and in that season. So there were other players actually outperforming. For example, Dimar Berbatov at that in that very season. He was playing for Tottenham later on in the year thereafter, signed by Manchester United. So you see that. And for sure, there's a lot of subjective judgment then coming in from when you observe it and you see the model telling you something completely different. But this is stimulating, and it should potentially update your priors. So your subjective priors, basically. So
and it forces you to lay out your priors clearly and on paper. So it's actually very important. So I would say definitely something like that. And if you have the predictions for the biggest number of players on a web page, and basically betting based on the model, saying that this player is going to overperform in respect to the market or underperform in respect to the market, that's an interesting thing. And also, as you were saying, for the individual rewards, where the name is extremely counts a lot, where you can see someone like Messi with who is an incredible player, but the number of times he's got the golden how is it called in English, Ballon d'Or, golden ball, I don't know. You could argue that some of these seasons where he did get the reward, and maybe there were other players who were actually overperforming him, but they don't have the name recognition, so they are not scrutinized as much, and they don't have the confirmation bias going in their favor, where it's like everybody's looking at Messi because they already know he's extremely good, so they just look at confirming the fact that he's incredible, which he is, but maybe not all the time, so as to get so many rewards. Like that. To me, that would be a really good way of demonstrating the utility of these methods. Basically, making it really concrete for the decision makers. So before we close up the show, I'd like to get back a bit on your personal experience with Bayes. And I'm curious, what was your main pain point on this project, the soccer factor model, and just in general, when you're using the Bayesian workflow, what is your main pain point right now?
Yeah, so in that project, I really have to admit that maybe I was lucky, but there wasn't really a huge pain point. I mean, it's not something publishable for a paper or so. It's just basically sketching the idea behind the model and basically showing the outline of the model, what it can give you. But when I was running it, the sampling worked pretty well. I didn't really, I don't remember any really big problems. So then when I looked at the model evaluation, everything looked fine. I mean, for example, how we can evaluate how well the model works is when you look at in this logistic regression at the area under the curve, for example. It's a popular metric, and it was in a reasonable ballpark, and that was fine for me, so that the model didn't the results were really what you would, or that it's kind of reliable, the results. So there was not much of a pain point, and that was also nice for me to see that it's a simple model and it works also pretty simply. And that was a project that I was pleased to see that there were not many obstacles that I had to overcome.
Nice. Yeah, that's good to hear. And so, in general, in the Bayesian workflow, do you identify something in your own learning, that is costing you to learn right now, that has cost you to learn, and you would like an easier way to have learned that?
I mean, I have to say that, for example, with all the different samplers that are out there, that's not my major field. I would like to learn much, much more about the inner workings of all these samplers.
Yeah.
I mean, I coded maybe one of the simpler ones myself, maybe once or so, but then I really resort to open source packages for that. But to really understand what's going on, I think, yeah, looking deeper into that, that's definitely something I would like to do and would need to do.
Mm-hmm.
But yeah, I think that's basically the math of it. I think is the most fascinating stuff, and how it really works and how it's then implemented in code. I think that's the most fascinating stuff. But yeah, the beauty of PyMC then is if you really are interested in the outcome and want a fast outcome, yeah, it's pretty intuitive. And, yeah.
Nice. Okay. Well, it's good to hear. Yeah, and I'm asking that, from a developer perspective and also teacher perspective. That's always interesting for me to get a peek in the learning experience of the people. Cool. So before we close up the show, is there a topic I didn't ask you about and that you'd like to mention?
Well, actually, it was yeah, my career hasn't progressed so much so far, so I think we covered everything there. So oh yeah, that's pretty interesting, and yeah, you covered actually everything.
Awesome. Yeah, we did record for a long time, so I'm not surprised. Yeah, and I'm happy I got to ask you the main thing I wanted to ask you, so that's super cool. In a reasonable amount of time, I'm sure the listeners will appreciate it, because the last two episodes were were the two longest of the whole podcast. So it's good to get back to reasonable amounts of time for people, I guess. Yeah, so before letting you go, I'm going to ask you the last two questions I ask every guest at the end of the show. So, Max, if you had unlimited time and resources, which problem would you try to solve?
Yeah, so I think one of the most popular answers is climate change, and definitely it's probably the most present problem, especially here in Milan currently. You really feel it. Um, but when I've been, or throughout the time I've been working on a bit of climate econometrics, let's say, forecasting RPC, as I saw what people are really doing in climate, and what, yeah, they're fascinating people out there, very, very intelligent people. So I think throwing money on me would be wasted in that regard. Um, I mean, what I'd be rather interested in is like, yeah, maybe implementing that into sports analytics, right? To allow teams to access data, to have access to data, and to kind of create that level playing field across players, and then really, yeah, it's an investment, and people spend a lot of, especially in investing and in banking and finance, spend a lot of time on crunching numbers, and why not do that with in sports as well if you have the data available. So yeah, I'd be very, very interested in working on that. That's for sure.
Yeah, I love it. Me too, for sure. That's a good one. And if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
Yeah, well, that's pretty a tough question, I have to say.
Yeah.
So no, really, it's yeah, there's so many amazing people out there, and when you read papers, it's really incredible what people are doing, and so yeah, there's so many people I would like to talk to. Well, one for sure, it's Frank Diebold, the guy who basically invited me to the University of Pennsylvania, because that was a defining point in my PhD, absolutely. But then if I could pick one, is because we should expand on your network, basically. It would be Ben Bernanke. He was former president of the Federal Reserve. He received the Nobel Prize in Economics. Well, you could say there's no Nobel Prize in Economics, but yeah, the Riksbank Prize last year for his work on banks and financial crises. And yeah, that would be super interesting to talk to him. He served his country basically. Then he was assistant professor, so how he managed all that. And yeah, that would be super interesting to talk to him. Phenomenal scholar. And I like reading his papers, so yeah, I think that would be super cool.
Nice. Yeah. Love it. Very nerdy answer. Awesome. Well, thanks a lot, Max. That was really interesting. You allowed me to rant about some of my pet peeves about data analytics and soccer. And I hope people learned a bit more. And of course, if they are curious, as usual, I will put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Max, for taking the time and being on this show.
Thanks, Alex. It was a pleasure.
You had to be a good breezy and change your predictions after.